we can look at if say that you wasn't coming to class or whatnot, and you needed to know what was going on and watch what's going on. Like I said, normally I would tell students to email me so that I could be reminded to stream, the class, the audio and the video of what's on the screen here. And somewhat got it set up to where it should be running. Like if you go to we go to Chrome or whatever, but get to YouTube, all right? If you go to YouTube, youtube.com, I'll tell you. And under YouTube, I've got it like CSCI1923, 1923, and it's not 0101, it's whatever today's date is, space 01-20.
I can see it right now.
Oh, you see it?
Yeah.
Right. And what you'll do, you'll did I do it right? It should be there.
I just got a bunch of sports stuff.
That's what I got too.
I saw it.
I might have typed something wrong. I don't think
You
so.
can search for your name, David.
Yeah, there we go. I just did CSCI 192. Oh, and I had chapter 1. So this one. And when you click on it, it will start streaming. Now, from whatever time you start streaming, it'll be like lapse. Like say if you start 10 minutes later than the stream started, you'll be 10 minutes behind or whatnot. But this is the stream, and what I could do, I'll just.
So what's?
I can hear you.
What's the deal with this? Like, what's the part?
Oh, like if you miss class,
Like if you can't make it to class, you can just watch the stream and see what we do.
and listen to the audio, right?
Okay, then.
Right. And so this will be pointed to the board, and you'll be able to see some of what we're talking about or whatnot. But then you can also hear the audio. Kind of like to give you a little assistance, because sometimes, for whatever reason, you might not be able to make it to class, and you really want to get it or do whatever. So this would kind of help. Yeah. So, and that's probably close, best I could somewhat get it, minus the other stuff. All right. So it's showing whatever's on the screen, and even I could pan it to the class, it's over here, turn it to the class. So let's go to the notes. Where I put my notes? All right. So, and if you notice what happened is it'll show the actual notes. All right. I left my clip. That's okay. All right. Anybody have any questions so far? Like I say, this is just the introduction. The first chapter is the introduction. And we somewhat stopped here when we're dealing with software. All right. We had talked about the CPU and how the CPU can only what? It only understands what?
Binary.
Binary, which is?
Zeros.
Zeros and ones, right. The zeros and ones. That's all it understands. So no matter what we type, what fifth generation language we type in, it has to be converted down to machine language, which is the zeros and ones, so that the computer can understand it. Now, what's happening on this page is showing you a compiler where someone types a program, it compiles it, and then it eventually turns into zeros and ones once they compile it. But then here they're showing you an interpreter. An interpreter same thing. They type the code, and it's interpreted. And what the compiler and the interpreter does, it removes all errors. Because a program with errors cannot execute. It will not execute. So you get all your errors out. And that's syntactical error, because you can have what type error? What's that term? When stuff is out of order. If I give you the instructions to get from here to governors, but it's out of order, it's not what? Huh? Begin with an L. Logical. See, when you create your algorithm is your step by step procedures, instructions, right? If any one of those are out of whack, then it's not logical, right? It can't get done. So you could get a program to execute, but it might be what? It might have a logical error to where if I'm writing a program to add 2 plus 2 and it's coming out to 8, logically that's wrong. But the program did run what? You took all the errors out, but you still have that logical error. All right? Now we talk about compiler and interpreter. Both of them do the same thing. Get the errors out, create the executable code so that you can run it. The difference is in the way it does it. A compiler, if you ever use a compiler, what it does when you write the code, it'll check every statement and try to find every single error that you may have. And sometimes you might have errors that may not be errors, but they're errors because something is dependent on it. Give you an example. How many people have ever brought their vehicle in to the mechanic shop for a problem and they put it on the machine, right? They're gonna give them a code, right? Is that necessarily the problem? No, but it could be something else prior to that. So if something else causing this to malfunction, then this gonna malfunction, but it's not necessarily what? That issue. And the same thing with a program, with a compiler. You might not declare a variable, so you won't get an error. But wherever you mention that variable, whether it's 15 different places, 2 different places, or whatever, you're gonna get an error at every single place where you reference that variable. All right? Now, that's how a compiler works. It looks through the program and try to find every single error. The thing is with compilers, you fix one thing, it might wipe out 20 errors, right? Because remember I said dependent on something, maybe dependent on something prior to. With an interpreter, what it does, it'll look at each individual line, making sure that what? It's correct. When it finds an error, it stops. Some programmers, they like interpreters. Some programmers, they love, compilers. It's just preference, all right? When they get an error, it stops. You fix that error, run it again. Then it might stop further down, fix that error, run it again, stop, until you get all the errors out, okay? So both of them have the same functionality, it just go about doing things in a different way, all right? All right? So that's compilers and interpreters. Now, when we use Visual Studio is considered an integrated development environment because you have your editor, you have the compiler, you can build projects, etc., all within that application. All right, so it's an integrated package. Now, if you wanted to, how would I say it? So you could use, if you were skilled enough, you could use Notepad to write your code and then put it in online GDB or put it in Visual Studio and try to compile it, right? But with that integrated package, what? Sometimes you see stuff that's color-coded, so you know that, hey, this is right, this is right. Oh, I missed a double quote because this should be a certain color. So that's what the integrated packages are. It's a total environment allowing you not to have to leave out to go do a lot of the different things, and everything can be compiled in that one application. All right? And like I say, the one we're using is or could use online GDB, not online GDB, Visual Studio. All right, let's see, can we see? All right, we somewhat touched on the type of software. All right, when we said there's basically two types, right? You got system software and what? Application software, period. System software is the software that actually runs the system, the operating system, etc. Application software is any software that's used by the user to do a specific task. All right, simply put. All right. So, like I say, system software, your operating system, backup software, utility software. That's system software. All right? And what happens with Microsoft, and I've worked with Microsoft. That's why I use that one. It has that plus some other stuff within it, right? Even though Windows is the operating system, it has what? The utility side of it, some software for the utilities, but then it also have applications such as what? WordPad, Notes, Paint, and Internet Explorer, all them different things in it that the user can use, which is application software. And you can buy others that you want to if you choose to. All right? So, here are some various operating systems. All right? Now, Windows, we know we've used Windows, right? iOS, which is pretty much what? Your little Mac, right? The iOS systems. Well, no, here you go, Mac iOS. Then you got the iOS. I think that's for your little devices. And then you got Linux. Linux, and it's like Linux, Unix, Solaris. They are somewhat tied together. And like I say, these were developed using the C++, all right, heavily with C++. Most of your servers, not all, but most of them, they was developed with C++, Linux or Unix, because you can, how would I say it? You can configure your operating system and design it just the way you want it. You can make it heavy on the resource side, or you can make it heavy on the application side, or fine tune it however you want. You can build packages to your satisfaction, right? Because this one is more or less open source, but then they have some that's proprietary. But Windows is totally proprietary, right? Because when you buy it, you buy that. That's it. Okay. All right. And even the Mac OS, proprietary, right? Whatever you buy, that's it. Right? You don't modify it. All right. And like I said, we talk about application programs. Any application or any program that you buy so that you can perform tasks. Who ever bought a software application? What's the name?
Microsoft Office.
Yeah, Office.
Adobe Photoshop.
Photoshop, you see? Huh?
Fruity Loops DAW.
Fruity Loops? What's that? I never heard of it, that's why I'm asking.
It's DAW, like digital audio.
All right, yeah, so audio player, copier, whatever, and slicing and whatever, right? So see, and that's for a specific task. The Microsoft specific task, either Word, Excel, Access, whatever. And Mr. Calkins said
Photoshop,
which what? Photo editing. So you see they have their specific purpose, all right? And these companies develop them based on the operating system they want them to run on, all right? All right, so, hey, we done finished the chapter, right? Hello? So when our test?
Thursday.
All right, test is Thursday. All right, so like I said, you can do the review questions. You can even do the end of chapter questions. They will help you on the test, all right? Now, let's get to chapter 2, designing a program. Now, as a beginner, and normally when an expert is creating a large program, they will have to sit down and come up with their logic as to how this program is going to work. And it's almost like right now, if I told you, well, I need you to plan a trip, driving to, I'll say, Santa Monica. Some people may know where it is, right? Some people may not. But what you'd have to do, sit down and what? Plan what? What's the direction? Where it is, how far it is, what's the direction, turns I gotta make, etc. Because when you start driving, you want to make sure you got enough gas, maybe, your vehicle can make it, all those things, correct? Same thing with writing code. When you got a problem or a program that you're facing, you gotta sit down and actually think it through. Okay, let's see if I understand this program. All right. Example: if I told you right now, I have a circle with a radius of 5, and I need you to write the code to find the circumference. If you didn't know what the circumference was, what you had to do? Huh? But I'm saying if you didn't know how to solve it. Huh? Do what? Okay.
Radius?
No, but I'm saying, the radius is 5. I want the circumference. If you didn't know how to find the circumference is the boundary. So how would you find, what would you do at least? What's the first thing? A lot of people say, I Google it. Yeah, but you'll find out what's the process in what? Calculating the circumference, right? You want to have an understanding as to what? How it's done, right? So you look at that, you might find a formula, and it says, okay, the circumference is pi r squared. I think that's right. Pi r squared. So now, you say, okay, what's pi? You got to have to look up what's pi, what it's equal to. You got me? So what you're doing your research as to what? Understanding what the problem is. And then maybe sitting down, writing it out on a piece of paper, what? The actual problem and how it works, right? Now, once you do that, now you need to put it in what? Programming form. You got me? So the same steps you followed to write it out, now you need to what? Code it out, all right? And you'd have that step-by-step procedure. Oh, I have knowns. What's known? The radius. What else known? Pi. What's unknown? Circumference. So you got 2 knowns and 1 unknown. Okay, well now how do I find out the circumference? Okay, circumference equal pi r squared. So now that's a formula. So now I have to put everything in that formula, right? C is equal to whatever pi is, 3.14 times 5. Or now I wouldn't say 5, I may give it a variable and make that variable equal to 5. And then what? Now C has a value. Now for the user, I would need to what? I would put that value, right? So just to find it out and not display it, what you doing? Doing nothing, right? So you as a programmer would have to sit down and go step by step by step, and we're gonna go over pseudocode and we're gonna go over flowcharting. Pseudocode is actually handwritten instructions, step by step instructions as to what to do. Flowcharting is some symbols used to show what it is that you're doing. All right? So you got several different symbols that you're gonna have a quiz on, and I'll probably post that for the weekend. The flowchart symbols, and the one we just use, I think about 5 or 6 basic symbols. All right, the process symbol, the decision symbol, the arrows, the flow arrows, the connector, and the terminal. All right, so those are the symbols that we use, and then we create our logic from that by using those symbols so that we can follow the logic. All right? All right. So, like I said, you would have to sit down, design it, and sometimes what? When you design your program, you may make a mistake, right? Just got to come back and what? Look through it, find the error, fix the error, and run it again, right? So, but like I said, there's nothing wrong with having to do it over, but if you sit down, understand the process, write it out, and then write the code, you would have less, I would say, attempts as to just trying to guess. Oh, well, let me change this. or let me change this, let me change this. You understand? So if you sit down, understand it, and write it out, you become more efficient at writing code. All right, and like it's showing you steps: design it, write the code, all right, correct the errors, test it. Now, right, you debug it, and then you might have to come back again, design it, write code, correct it, test it, and debug it until you get all the bugs out. And remember, we got what? Syntax errors and what those other errors? Logical errors. Correct. All right. And again, the first and the most important thing is understanding what it is you have to do. And a lot of students, when I give an assignment sometimes, give me an example. I think one of my assignments, I'll say, okay, write a program that will double space the output of your name, then your major, and then the semester.
Like double space all in one line?
Double spacing, but your name, your major, and then the semester. What's double space?
It's /n.
But I'm saying, when I write something in double space, how many lines I'm putting in between?
1.
You see, 1 in between, but I'm going down 2. You understand? Because I'm typing something, going down 1 line, right? Going down the next line, type something. Going down the next line, going down the next, and type. So what? The key is what? Understanding it. But sometimes we as humans, we do what? Oh, I know how to do it. Oh, I know what it is. And we do it. And when I grade it, oh, well, Mr. Vester, I thought, But if you, like I say, the best thing to do, I would say, when you write your code, ask somebody, how you do your program, what it was, or double spaces, double space, this is how, whatever. And compare. And you're like, oh, okay, I figured it was this, that, and the other. And so you can get all your points. And that's how it is on the job in the real world. When you're given a task to do, it's no harm to go ask an office mate or somebody, hey, I had this project, I did this, that, could you look over and see whatever, if there's something I missed or whatever. You understand? So that you won't get in a presentation, it's like, oh, I got this here. Oh, I messed up on, you understand? So it's good to do that, but a lot of computer scientists, we introverts, and we're like, oh, I got it. I know what I'm doing, And so, sometimes it hurt us, but like I said, hopefully we can kind of get out of it and be able to work in groups and talk and whatnot. All right. And like I say, determine the steps that it takes. We always need to know the step-by-step process. And I'm going to tell you why I say that. Again, as humans, even when we might do a math problem, what we do? Oh, I know what 2 + 2 is. Oh, I know what this is. And we overlook a step. If you do that on the computer, you may have messed up. You understand? You have to give the computer every individual thing that it needs so that it can function properly. You got what I'm saying? You can't just say, take for granted it knows something. It has to be given, or it has to be calculated. It has to be whatever, right? So that's something that we do sometimes as humans. We just take for granted something, it should be understood. Not with computer science. You have to give it to it. You have to feed that information in. I'll give you an example. If a person has never received a driver's license, right? Then if they get pulled over by the cop, will their information be in the police database? No, because they never had a driver's license. You understand what I'm saying? Only people who what? Actually went and registered to have a driver's license. So, and that's the same thing goes with the computer program. If you never give it the information, it won't just up in there and say, oh, I'm gonna grab this and I know this is what they meant. Don't work like that, okay? So make sure you give it all of the information that is needed. And like I said, most times when you write code, you wanna know what's known and what's unknown, the given and what's not given, right? What you're looking for, what result you're looking for. All right? Determining the step that must be taken, that's your algorithm, okay? What should I do first? What should I do next? What should I do next? What should I do next? And on and on and on. Because as we go through these chapters, we're gonna start getting into if statements, where we're gonna be like, okay, you do this, but if something is something, then we're gonna do this. If it's not, then we do something else. You got what I'm saying? And then further on, we're gonna get to something where I say, okay, while this is less than whatever, do this. So you might be performing the same groups of code multiple times. All right, all that's coding. All right. So we gotta understand. You got to understand each step. That's your algorithm. And I'm gonna tell you, the class I told you earlier. Coming to class, I don't penalize you, but most times when you miss class, you miss out on a whole lot. And then when we move to that next chapter, it's like you got to try to recover and catch up to it. And sometimes, you know, students don't do well when that happens. All right? So try to make it to class, try to do it, and do your homework. Try to do your homework. I would rather you do the homework, come to class with questions, and then turn it in correctly, rather than like, oh, well, I don't understand it, so I'm just not gonna do it.